All right, in the next part of the assignment, the instructions are real important, and I had not noticed these before. It said solve each system using any method. Now, the methods you have are graphing. You're probably not going to choose it, but if you were, you would want each of the equations in y equals mx plus b form so that you could graph them. That's what we did, I guess, in 6-1. The second method is substitution. I use substitution anytime one of the equations says y equals or x equals, or it would be easy to get them like that. Then I choose the elimination method, which the books I've been using call it addition, but it's when you have opposite coefficients for x or y. So in this instruction, solve each system using any method, explain why you chose it. It will be because of the format. So let's go ahead and take a look at these. And I will address what to do when you have the decimal fractions. Does it make a difference? We'll see. All right, number 32. The system is y equals 2.5x, and the other one is 2x plus 3, misread. It is 2y plus 3x is 32. All right, for this one, I'm going to choose substitution because one equation is in the form y equals. That's my reasoning. All right, so now I'm going to see this first equation is in the y equals format. So I'm going to take this value for y and I'm going to put it in the place of y. So I am going to substitute. I have 2 parentheses, 2.5x, it doesn't bother me that it's a decimal, plus 3x is equal to 32. So when I multiply that, I get 5x plus 3x is 32, which means 8x is 32, divide, and x is 4. So find the other variable, which is y. I'm going to choose, as I always do when I've used substitution, the one with the circle. So I'm going to choose y equals 2.5x, plug that in, y equals 2.5 times 4, so y is 10. Your ordered pair is 4, 10. Okay, oops, there we go. Let's look at 33. Remember, just pause if I start to move a problem out of your way and you're not through thinking about it. I have 2x plus y is equal to 4, and I have 6x plus 7y is equal to 12. This is not ready for substitution or for elimination, but it would be pretty easy to get it ready for substitution by solving for this y. So I'm going to take this one and I'm going to solve for y. So here I go with my reasoning. Substitution because it is easy to solve, sorry, dog in the background, for y. So I have 2x plus y is 4. I'm going to subtract 2x, And I'm going to pause this video to make my dog be quiet if she doesn't hush up. There we go. So now the system has become, and you don't necessarily have to rewrite it, but the system has become y equals negative 2x plus 4. Easy process to make that happen. And 6x plus 7y is 12. I am going to take this as a value for y, and I'm going to plug it in the place of y. So I have 6x plus 7 times negative 2x plus 4 equals 12. So I have 6x, I'm going to use the distributive property, minus 14x, because positive times negative, plus 28 is equal to 12. Positive 6x and negative 14x is negative 8x, plus 28 is 12. Subtract 28 from both sides. I have those cancel. I have negative 8x is equal to negative 16. Be careful with your signs. Divide by negative 8, and x is 2. Find y. And because I use substitution, I have a circled equation. Y is equal to negative 2x plus 4. Let's take that and plug it in. Y is equal to negative 2 times 2 plus 4. Y is equal to negative 4 plus 4. Y is equal to 0. So it looks like the ordered pair is 2, 0. All right, going on to number 34. So I have 3x plus 2y is 5, and 4x plus 5y is 16. Now I'm going to tell you this problem, none of the methods are going to be easy. They're just not going to be easy. It's not easy to solve for this x, to solve for this y, to solve for this x, solve for this y. You're going to build a bunch of fractions. I'm not going to use substitution. When you use the elimination method, and you haven't done one like this, but when you use it and you don't have opposites or super easy ways to get opposites, what you have to do, and let me do this with maybe a highlighter, is if you look at these, or if you look at these, you're thinking about, what could I change them both into, but one positive and one negative? It's the same thing as, and I know this is going to sound strange because it comes usually from studying fractions, the least common multiple. So what do 3 and 4 both go into? They both go into 12. What do 2 and 5 both go into? They both go into 10. You could turn one of these into positive 12 and the other into negative 12, or the same thing here with the y's. So I think I'm going to target the y's. What does that mean? That means that I have to change both of these equations. In order to turn the 2 of the 2y into a 10, I would have to multiply by 5. In order to turn the 5 of the 5y into 10, I would need to multiply by 2. But one of them has to be negative because they have to be opposites. It doesn't matter which one you choose, but one of them has to become a negative. All right, so here I go. You've got to multiply the top equation totally by 5. Okay, I need to stop for just a minute. I chose addition because it was, well, let's see, it was not difficult to make opposite coefficients on the y's. Honestly, I would be tempted to say, because it would be really nasty with substitution. Okay, but this is probably a better answer. So I'm going to multiply everything by 5. 3x times 5 is 15x. 2y times 5 is 10y. Don't forget 5 times 5 is 25. That is a super common mistake, to forget to multiply the constant, but don't forget it. Now I'm going to multiply the second equation by -2. -2 times 4x is -8x. -2 times 5y is -10y. And -2 times 16 is -32. So let me pause for a minute. When I looked at the problem originally, I saw that I did not have opposites with the x's. Look at the original. I did not have opposites with the y's. To make opposites, it's like turning those into their common denominator. It's called a least common multiple. So what do 3 and 4 both go into? 12. What do 2 and 5 both go into? 10. So you choose which one to target, then pick these numbers based on what it will take to turn the 2 into a 10. I chose 5. To turn the 5 into a 10, I chose 2, but I needed a negative. All right, going on with the problem. So I have 7x, those are gone, is equal to, looks like -7. Divide by 7, x is -1. Now I need to pick an equation to find y. I typically, unless there's a bunch of fractions, I'll pick one of the original ones, but you're welcome to pick one of the modified ones. All right, so I'm going to pick 3x plus 2y is 5. That was the original. Plug in 3 times -1 plus 2y is 5. -3 plus 2y is 5. Add 3. So 2y is 8. Y is 4. Let's find x. You get to pick whichever equation you want. I'm going to pick 3x plus 2y is 5. Oh, I'm so sorry. Goodness, I got totally distracted. I'd already found it. I could have done it again, but I have both pieces of this. I'm so sorry about that. So I have, as an ordered pair, -1, 4. I had scrolled up and I just lost my concentration, I suppose. So there's your ordered pair. All right, let's look at 35. All right, I have y equals 2/3 x plus 1, and 2x plus 3y is 27. I'm going to use substitution because one equation is in the form y equals. Okay, so I'm going to pick this. It is what y is, and I'm going to put it in the place of y in the other equation. So I have 2, this is my substitution. You've noticed, probably if you've seen my work, that I like to label to kind of give a narrative to what I'm doing. So if somebody looks at my problem, they know what I was doing in that step. So substitution, 2x plus 3 parentheses, 2/3 x plus 1 close is equal to 27. So there's my substitution. So I have 2x plus. Well, this isn't too bad because when I multiply those 3's divide out and I left with 2x, and then I multiplied 3 there and I get plus 3 is equal to 27. So 4x plus 3 is 27. Subtract 3. 4x is 24, which means x is 6. Now I need to find y, and I'm going to use y is equal to 2/3 x plus 1. Y is equal to 2/3 times, I'm going to write that 6 as 6 over 1 plus 1. Now 3 goes in there once, 3 goes in there 2 times. I have y is equal to 4 plus 1. Y is equal to 5. Looks like my ordered pair solution is 6, 5. All right, number 36. You have x plus y is 1.5, and you have 2x plus y is 1. All right, I'm going to choose elimination because it's easy to get opposite coefficients on the y's. So one of them is positive y, one of them, well, I'm sorry, they're both positive y, but one of them needs to be a negative y. So I choose to multiply the second equation, but again, it does not matter, and that will make that into a negative y. So here we go. I have x plus y is 1.5. The decimal does not bother me. I hope it doesn't bother you. 2x times negative 1 is negative 2x. Y times negative 1 is negative y. And 1 times negative 1 is negative 1. Add these together. Positive x and negative 2x gives me negative x. That's a 1. That's really a negative 1. Those are gone, is equal to 0.5, which means, probably do that in your head, x is negative 0.5. Okay, so now find y. It does not matter. I'll take the first equation. X plus y is 1.5. Negative 0.5 plus y is 1.5. Add 0.5 to both sides. So y is 2. So it looks like my ordered pair is negative 0.5, comma 2. Okay, the last one starts out looking a little bit on the ugly side, but here we go. Number 37. I have 1/3 x plus 1/2 y is 0. And I have 1/2 x plus 1/5 y is 11/5. Now, different people might tell you different things about this, and I'm not saying this is by any means the only method, but it is the method I would choose. I would tell my students to completely get rid of the fractions before you make any further decisions. So, looking at just the first equation, the common denominator is 6, and if I multiply everything by 6, then I will no longer have fractions. So I'm going to multiply that by 6, and that by 6, and that by 6, and I will get 3 goes into 6 2 times, so I have 2x. 2 goes into 6 3 times, plus 3y is equal to still 0. Okay, I'm not really any closer to solving it, but the format, I think, is improved. The second equation, what would I multiply by to eliminate all these fractions? Well, the LCD is 10. So I'm going to multiply 10 here, 10 here, and 10 here. That will give me 2 goes into 10 5 times, so I have 5x. 5 goes into 10 2 times, so I have 2y is equal to 5 goes into 10 2 times, and I have 22. Now, somebody could argue that maybe that was an extra step that you didn't have to do because you're going to have to multiply again. I think it just makes a little bit more sense. It's a little bit easier to look at. Your teacher might or might not agree with me. All right, now I need to either build, I don't want to use substitution. I'm going, now that it's in this format, I make a decision that I will use elimination. And honestly, oh my goodness, I can't even write neatly. Because it is not difficult to create opposite coefficients. All right, now if you wanted to get opposite coefficients with the x's, the least common multiple is 10. 2 and 5 both go into 10. If you wanted to do it with the y's, the least common multiple is 6. As a rule for myself, I typically target the ones where the numbers are smaller. It's just my particular rule. Now, I'm going to do this again. What would you have to multiply 3 by to turn it into 6? Well, 2. What would you have to multiply 2 by to turn it into 6? 3. One of them needs to be negative because your goal is to get a pair of opposites. I just throw it on the bottom usually. So here I go. 2 times 2x is 4x. 2 times 3y is 6y. And 2 times 0 is 0. Negative 3 times 5x is negative 15x. Negative 3 times 2y is negative 6y. And negative 3 times 22 is negative 66. Now I have a pair of opposites with my y's. Add here, I have negative 11x is equal to negative 66. Divide by negative 11, and x is 6. Pick one to find y. So I have 2x plus 3y is 0. So that's 2 times 6 plus 3y is 0. 12 plus 3y is 0. Subtract 12. 3y is negative 12, which means y will be negative 4. My ordered pair is 6, negative 4. Make sure that you write the ordered pair in XY order, even if you find the y first in the problem. All right, so that's all the problems. I hope that you find the video helpful and you can send back any particular questions that still pertain. Good luck.